Now, the second part of this is to identify the stereochemical configurations of this molecule. So we want to look if this is an S configuration or an R configuration. Now to do that, we have to start numbering our substituents. In this case, this one right here, this is going to be labeled a 4. The hydrogen is labeled a 4 as it is the lowest substituent. We base the ranking off of atomic number, in addition to if there are multiple carbons present, such in this case, we have the carbon here, here, and here. Obviously, those carbons have the same atomic number. However, we have to go one out, or however number amounts out, in order to find a difference in the atomic number. So going out one out here, this is bonded to a nitrogen. Going one out here, this is bonded to a oxygen. Now, it's also important to note, oxygen, double bonds are counted twice. So technically, in terms of naming this with the Ingold rolling name scheme, this carbon in particular here technically would just appear as single bonded to two different carbons. Now, this is not the correct skeletal form. This is just the naming scheme. So this is single bonded to a nitrogen. This is a carbon, which is double bond. So double bonded to an oxygen, single bonded to a nitrogen. 2, 4, 6, and then 2, 4, 6, 8. Okay. So that's all the bonds. Obviously, this is definitely our highest order substituent. If you were to add up the mass of nitrogen with oxygen and oxygen again, that's obviously greater than just the mass with carbon and nitrogen by itself. That being said, this is the second strongest. And the third strongest is going to go to this carbon double bond down here. Now, we are very lucky considering that the hydrogen here is drawn with a hash, meaning it is facing um, away from us, not towards us, but away from us in the molecule. That allows us to easily uh, decide if this is an R or an S configuration. So the next part of after deciding the order of the substituents, we want to go from the highest to the second highest. Now that is easily done here. This is a clockwise motion where the 1 goes to the 2 goes to the 3, and the 3 would go to the 4. It's fine to jump over the 4 in this circumstance. Um, really, that hydrogen can be positioned elsewhere. It would just depend on how you would draw the molecule. To be fair, the hydrogen itself is just orthogonal, sort of, to this Y shape in the carbons here. So if you were to assume this was a Y shape um, in the skeletal structure, this hydrogen is literally just orthogonal to the 3 points right here, and that's why it appears like that. So it's facing away from us. So considering that is doing a clockwise motion, we can actually identify this as an R configuration. Um, and now we can move on to our other stereocenter. So this is bonded to a nitrogen, a carbon, and another carbon, which is single bonded to a carbon down here. This counts as technically 3 carbon bonds. This is counted as a hydrogen and a hydrogen. So this is lowest priority. Actually, I'm going to use a different color. Okay, sorry about that. So that's carbon, single bonded to carbon. It is part of a double bond, as well as bonded to this carbon down here. Now this is bonded to a carbon here, which is single bonded to this carbon, and this is bonded to 2 hydrogens. And this is the lowest priority. This is the highest priority. This is second highest priority, and this is third highest. Now the hydrogen here is facing towards us, so in order to mitigate that, we can still do our rotation, except we have to just basically reverse it at the very end to account for the fact that we have a inward facing hydrogen. So this nitrogen would move here. This would ordinarily be an S configuration. However, this hydrogen is facing outwards, so it is actually an R configuration. So those are the 2 stereocenters of the LSD and its stereochemical configurations.